In this video, I'm going to talk about a couple of really interesting books that I've read recently that introduce the topic of predictive processing. Then, in a series of short videos, I'm going to explore some of the key concepts covered in the books and talk about some of the implications of the theory. So, the two books I'm going to focus on are the first one is by Andy Clark, called Surfing Uncertainty. It's published in 2016, and this was my first introduction to predictive processing. And right from the start, I recognise this is a book that requires close reading. There are some parts of the book, particularly the section on movement and action, that are pretty tough going. However, on the whole, I found the topic of predictive processing fascinating, and it was something that was new and refreshing for me. I was also impressed by the lengths that Clark has gone to properly support his claims and offer opportunities for further reading. I mean, there's literally 40 pages of references at the end of the book, which is pretty mad for a fairly short book. But after finishing the book, I was left with a feeling that I kind of needed to read more before moving on to some of this further reading. And I was looking for an introductory book by another author so I could get a different perspective on the same topic. So I looked online, and The Predictive Mind by Jacob Howie had good reviews, and it was a natural choice for me, so I went ahead and bought that. I found his style of writing a lot easier to understand. It's a nice read, and it kind of helped me consolidate some of the things that I'd learned from Clark's book. I'd give both books 4 out of 5 stars, or 4.5 out of 5 stars. They're definitely worth reading if you're interested in the more empirical side of the philosophy of mind. But given the chance, I probably had read The Predictive Mind first. I think it sets the scene better to then go and read Surfing Uncertainty. Okay, so what is predictive processing? I put up a definition up here that predictive processing is a theory of brain function in which the brain is constantly generating and updating a mental model of the environment. So really, it's a theory. It's a computational theory, and under this theory, it means that what we perceive is determined by the currently best performing predictions. And it's kind of nicely summed up by this following quote: perception is a controlled hallucination. This sounds fairly radical, but when you look at the details of the theory, it all seems to fit quite nicely together. So what is it up against? What's this theory where we're generating these different models? What is this up against? Well, although it's a slight caricature, the classical theories of sensory processing view the brain as passive and stimulus-driven. By contrast, predictive processing emphasizes the constructive nature of perception, and it views perception as an active and highly selective process. Okay, now let's have a look at some of the origins of the theory, some of the sort of initial foundations of the theory. And in this, it posits that in many ways our brain is like a person trapped in a box, which I've tried to show here with my rubbish diagram. It has no direct access to the causes out there in the world. It only has access to the effects of those causes on the senses. So in this example, something falling on the ground and making a loud sound. When we hear it, we get the effect of the cause on our senses in terms of the sound on our auditory system. Therefore, this means that the brain has to rely on inference to get a grip on the causal structure of the world. So it has to make inferences to make sense of the causes out there in the world, because it doesn't have this direct access. And the inferences about the causes are made using the available sensory evidence. Now, some of you might sort of notice this statement sounds a bit similar to Immanuel Kant's assertions about things in themselves. And there might be something to this. And if you're interested, I'm going to put a link to the paper in the video description that positions Kant as the forefather of predictive processing. Okay, have a look at this image. You might have seen it before. It's quite a classical sort of image. And see if you can make any sense of it. See if you can see any sort of figures, anything in there that makes sense to you. And if you've never seen this image before, it might appear that there's just a random collection of dots and splodges. But after you discover, and I'm going to just highlight it here and ruin the fun here, I'm just subtly highlighting that there's a Dalmatian dog in the sort of bottom right-hand corner. And once you see this, it's pretty difficult to unsee it. In fact, this dog will pop out within seconds of looking at the picture, probably for the rest of your lifetime. So if I show you this image again, and for those who have already seen it, you see the Dalmatian very, very quickly, within seconds. Why is this relevant? Well, this is the type of image that is reflective of the sort of sensory information that we constantly receive, particularly visually. The retina is constantly receiving a barrage of dots and splodges and shadows and half-occluded moving forms, flashing lights. Okay, so there's a lot of noise, there's a lot going on, and it's hard to track exactly what's going on. Buried within this noise are statistical regularities that can help us build hypotheses about the causes of the sensory data. So there might be a lot of noise, but there are regularities, and we can use these regularities to build hypotheses, so we can build models and ideas about the causes of the sensory data. The winning hypothesis is what we perceive. So we perceive the Dalmatian and continue to do so for many years because it's our brain's best inference from the sensory evidence. In my next video, I'm going to introduce the mechanism in predictive processing that enables the brain to make these